ribose and deoxyribose. Those were pentose sugar. Now here we are dealing with diasaccharide. What is diasaccharide? Diasaccharide basically it is two monosaccharides joined together. For example, see maltose. So maltose means two molecules of glucose, they are joined together. Now if you remember the drawing of the structural diagram of this glucose molecule, you see here glucose, we already know that this is an aldose sugar. Okay. Now the functional group here, if it is forms a ring structure, see here in the fifth position we have the oxygen here and they are joined together by a glycosidic bond. Okay. Now here is molecule number 1 and here is molecule number 2. Okay. So here you see this position, that means 1 and 4. See, one position of carbon here and this is the fourth carbon of this, they join together by a glycosidic bond. So when this glycosidic bond is formed here, you see here this portion and this portion both reduces this one in the first position, that aldehyde is lost, but in the second the OH is lost. Okay. So since they lose one aldehyde and another one still has a functional group, that means it can be still called aldose sugar. One functional group is already retained and this glycosidic bond between 1 and 4. So we say that in maltose, that is made up of 1 glucose and 1 glucose, we have 1,4 glycosidic bond and hence it is still a reducing sugar. See, if it retains the aldehyde group as the functional group is retained, we call it as a reducing sugar. Now you see here, second case we have a sucrose molecule. Now sucrose molecule is again a diasaccharide and it is made up of 1 molecule of glucose and 1 molecule of fructose. Okay, so here you see glucose is 1 molecule of aldehyde is there and 1 OH, this is for this one. See, glucose and fructose together form the cane sugar. What is cane sugar? It is extracted from sugar cane. Okay. Now if you see it is this is fructose. The second molecule is fructose and this is a glucose and here you can see that this is a fumarose. What is fumarose? It is a 4 carbon chain. This is fumarose, F-U-M-U-R-A-C, fumarose, and this is pyranose. This is a pyrenoid ring and here it is fumarose. Pyrenoid means 5, fumarose means 4. So here 1 5 carbon, that is the glucose molecule, gets attached to this one. Now here you see in this position we have already the aldehyde as a functional group and here it is again 1 and 2. This is the 1 and this is the second position. Okay, so this second position here they have got a glycosidic bond is there and during this formation both, see, the first glucose loses its aldehyde functional group and the fructose loses its ketose group. So since the aldehyde and the ketose both the functional group are lost, they turn into non-reducing sugar. So hence this sucrose is a non-reducing sugar. Now another third molecule is lactose. Lactose is basically a molecule of 1 glucose molecule and another one is galactose molecule and here we have 1 and 4 glycosidic bond, that means the first position of glucose and fourth position of galactose. And since you know this aldehyde group is retained, okay, so only the OH portion is lost. So since the aldehyde portion is retained, so we call it as a reducing sugar. So since the reducing sugar or the reducing property of the molecule depends on the functional group. So I repeat again, see that in the maltose we have the aldehyde group is retained in 1 molecule and here is first one the aldehyde molecule is there in position here, but in this position the aldehyde molecule is lost by the formation of glycosidic bond, 1,4 glycosidic bond. So since this functional group is present here, we call it as an aldose sugar and it is a reducing sugar. Now here the sucrose, you see glucose and fructose is there. So glucose and fructose, again it is a cane sugar, and see glucose and fructose, they both loses the aldehyde and the ketose group. So since both the aldehyde and ketose is there, so this sucrose is a non-reducing sugar. And another, the lactose, here you know, here one functional group, the aldehyde group is already retaining here. Okay, so we call it as a galactose, only OH is lost, so they have the aldehyde group to it, so it is called a reducing sugar. So functional group depends on this unit. Now again we have trisaccharide. What is trisaccharide? Trisaccharide is a molecule that is made up of 3 monosaccharides. See, one glucose in trisaccharide. See, we have one trisaccharide that is known as raffinose. This raffinose is a sugar found in sugar beet and it is found in coffee. This is not a sweet tasting sugar. Okay, so we have one molecule of glucose, one molecule of fructose and one molecule of galactose. Okay, now you see this trisaccharide, you see 1 and 2, 1 sugar monosaccharide, 2 sugars disaccharide, but this trisaccharide 3 sugar molecule, 4 sugar molecule and 5 sugar molecule, that means tetrasaccharide, pentasaccharide, we don't read it that way, we take all together as oligosaccharide. Okay, now you see up to lactose we have the micromolecules, and trisaccharide, oligosaccharide, they are macromolecule. That means their weight is more than 10 dalton. Okay. Now one thing you see, the formula of glucose is C6H12O6. Formula of fructose is C6H12O6. Now since one glycosidic bond is formed, see whenever one single glycosidic bond is formed, there is always elimination of water. So from this, when this disaccharide is formed, the H2O is eliminated. Okay, this is eliminated during the bond formation. So C6 comes to C12, H12 comes to 24. But here 2 hydrogen is lost. So we have an H22 and O6 and we have one molecule of oxygen here. So instead of 12 we write O11. So C6H22O11 is our formula